Welcome to Math Tutorials. In this video, we are solving every question of exercise 10.3 of Chapter 10, Vector Algebra, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 10.3 is the scalar product. Angles, projections, perpendicularity conditions, the unit vector zero-sum identity, and geometric applications, closing with one multiple choice. Here is the list, grouped. Question 1 of the scalar product. Magnitudes and dot product given, angle wanted. The cosine formula inverts directly. Cosine theta is the dot over the product of magnitudes. Root 6 over 2 root 3, 1 over root 2. Question 2. Component-wise dot product first. Both magnitudes are root 14. The dot is 3 plus 4 plus 3, 10. Each magnitude is root 14. Cosine 5/7. Question 3. The projection formula, dot over the target's magnitude. Perpendicular vectors have zero projection. The dot is 1 minus 1, 0. The projection is 0. Question 4. The same formula with bigger numbers. The target magnitude is root 114. The dot is 7 minus 3 plus 56, 60. Divide by root 114. Question 5. 3/7 scaled vectors, check lengths and pairwise dots, 49 under each root, zeros in each dot. Each squared magnitude is 4 plus 9 plus 36 over 49. 1. All unit vectors. Each pairwise dot vanishes. 6 minus 18 plus 12, and so forth, all 0. Question 6. The difference of squares identity for vectors. Substituting, the magnitude ratio solves it. The product expands to magnitude a squared minus magnitude b squared equal 8. With a equal 8b, 63b squared is 8. Solve both magnitudes with rationalized roots. Question 7. Expand by distributivity. The cross terms combine since the dot commutes. 6a squared plus 21 minus 10 mixed terms minus 35b squared. Question 8. Equal magnitudes known angle and dot. Cosine of 60 degrees is 1/2. The dot is magnitude squared times half, equal to half. Magnitude 1 for both. Question 9. The difference of squares once more. The unit vector contributes exactly 1. X squared minus 1 equals 12. Magnitude root 13. Question 10. Perpendicularity means the dot with c vanishes. One linear equation in lambda. The combination has components 2 minus lambda, 2 plus 2 lambda, 3 plus lambda, dotting with c. 8 minus lambda equals 0. Question 11. Another difference of squares in disguise. The mixed terms cancel by commutativity. The dot expands to a squared b squared minus b squared a squared. 0, hence perpendicular. Question 12. The first condition pins a completely. Then the second condition says nothing about b. A dot is the squared magnitude, so it is the 0 vector. Then a dot b is 0 for every b. B is arbitrary. Question 13. Square the zero sum. Each unit vector contributes 1 to the square. Squaring 3 plus twice the wanted sum equals 0, so the sum is minus 3/2. Question 14. The 0 dot does not force a 0 vector. Perpendicular non-zero vectors give the counterexample. Take I hat and j hat, both non-zero. 0. The converse fails. Question 15. The angle at B between the vectors B and BC. Two vectors from B, one cosine. BA is 2, 2, 3 and BC is 1, 1, 2, 10. Magnitudes root 17 and root 6. Question 16. Compare the joining vectors. Identical vectors chain the points onto one line. A B and BC are both 1, 4, minus 4. BC continues a B exactly, so the 3 points are collinear. Question 17. Position vectors of the corners. Compute the sides and test Pythagoras. The squared side lengths tell the story. The sides have squared lengths 41, 6, and 35, and 6 plus 35 is 41. A right angle. Question 18, the last one, multiple choice. When does scaling produce length 1? The magnitudes multiply. Magnitude of lambda is modulus lambda times A equal to 1 exactly when it is 1 over modulus lambda. Option D. That completes all 18 questions of exercise 10.3. In the next video, we will take up exercise 10.4 on the vector product. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.